We start with a well-known basic terrain, which is mostly based on isolines, only with a selective noise with a general strength of 51. The noise is enabled for all levels with 100%. We want to now try to use a selection to get the effect that the higher parts of the terrains are rough while the lower parts are smooth. And so we will use for the selective noise a selection and try to control with this the power of the noise for the generation. Well, that's the first part. Let's switch to the selectors panel. We have always the minimum of one selection in the list which is not removable. We can add selections with the add button or import selections with the import button. The create button is for creating a selection for the 2D view. We only need it for get it visible in the 2D view and to create it before we can export it, else we do not need to create a selection. Well, first, when we work with the selections, we want to see something, so we have a good control what we have selected. So we switch to the render panel. We have one shader. And as distribution, we use the selection 0. I will now enable the selection height. We'll set it to the half height of the terrain. And now push render. Oh, to get it visible, we need another color than the base color. Push again render. And now it is good, clear, visible. We have selected now all the parts of the terrain which are between the min height and the max height of the selection. We have such sliders for all of the selection types, but we first only want to have a look at the height selection, which is mostly used and it is very important. If we use this selection, we can simply see all between the min height value and all between the max height value is selected. And let's call it the selection power is here 100%. So it is selected with the full power. To use such selections for rendering or for creating, we will use it later for creating, such hard borders are often not what we need. We need a smooth blending. For creating the blending is a fuzzy slider. The fuzzy slider enlarges the selection, but blends this enlarged part up to 0. So, for example, if we now enlarge the selection by 50%, let's have a look at the result. We can see that the selection has grown, but the grown part is blended out. And 50% means that from the max height to the max possible value, it is blended out to 50% of this height. The max height of the terrain is 4,854, and 50% means the difference between the max height and the set height, and from the difference 50%. We can also use the fuzzy slider for the min height, and as we can see, the sliders are separated for maximum control. And if we render it now, we see now the selection has grown from the min height to the lowest part of the terrain and is also blended. Okay, we want to try to use the selection to apply a low noise to the lower parts of the terrain and a high noise to the higher parts of the terrain. So we need a selection from the low to the high parts of the terrain. I will set now the min height to the maximum possible value and the fuzzy slider to 100%. That would mean from this height, from 4854, the selection will blend it out up to the height of 0. That's exactly what we wanted. And you will see this typical selection, height min to maximum, fuzzy slider to 100%, is a very often used selection because it selects the whole height of the terrain with a total blend. Well, we switch to the filter panel. Selective noise, as the name says, has the possibility to use a selection. We will use now the selection 0. Push generate and see if there is a difference. Yes, as we can see, there was a difference, but not very much. Well, as you might remember, the definition of the selective noise is that all of the selective noise which is selected by 100% power will use only the selective noise, else the basic noise is used. So I reduce now the strength of the basic noise to 0. Let's generate again. And that's what we want. The strength of the selective noise from 51 is now only applied to the maximum height with the full power, and then the power of the noise gets lower and lower. I will now simply use a gray color. No, I will simply reduce the alpha power to get a gray look, where we can see better the structure of the terrain. We can now increase the noise strength a bit, because only very few parts get the total strength of that. And as we can see, let's switch a bit the view. We have now applied the highest noise to the highest parts, and the lower the terrain gets, the lower the noise and the roughness of the terrain is. This is very often in nature so that the higher parts had strong roughness because of the erosion power, mostly thermal erosion, while the lower parts are erased out, for example, by earlier glaciation, and are not so rough. Switch back to the other view. Well, so we have now applied a selection to the selective noise. I will add now the filter mountain ridged, well known, without using the selection. Wait some seconds. Well, as we can see, and you might remember that the shape filters orientate on the slope of the terrain and the roughness of the terrain, and though the power of the filters mostly depends on the roughness. Here now we have added the mountain ridge filter to the whole terrain. But we can also restrict this filter to the selection. We can use the selection as often as we want. And the difference is very good visible. The mountain ridge filter is now only used for the highest parts. But well, we can see that I think it's not just what we want, because the mountain ridge filter is nearly not visible, only here in some parts and here at the edges, else it looks simply rough. So we want to use a selection, a height selection, but with another power in the higher parts. We have two possibilities. We went to the selectors panel, add a second selection for the height, and for example reduce the min height a bit to get more power to the max height. Or we can use a filter curve. A filter curve, if we push this button, we have the filter curve editor. I will now increase, as you can see, the power of the higher parts. Push generate again. We see no great difference. Try it again. Looks like a bug that has to be fixed. Now we will see the difference. Yes, here we see it. So we have used now the same selection for selective noise and mountain ridge, but we have additional control over the selection with the filter curve. I have now increased the basic power at all. And as you can see, the mountain ridge filter now also have power to the lower parts of the terrain. So the combination of selectors, where we can control the selection very detailed, and the filter curve gives us really control how to use the selection, and the filter curve enable us not to use for every filter which we apply, or for in the rendering for every shader to create a new selection, but we can use the same selection for many different filters or shaders. And for example, if we now use the filter curve and I set simply all to the maximum, we get the same result as we would apply it to the whole terrain. Is to see. We can also make discretes so that it is not all applied to the whole terrain, but to some parts. It's really nice to play with these curves to get different results, and we have a surprising terraced result by simply applying the mountain ridge filter with different strength to different heights. Well, that now was all a bit fast. Just again, take a look at the filter curve editor. I will reset this curve and create the selection to explain it a bit more. Well, the horizontal axis stands for the input values, and the vertical axis stands for the output values. Well, the input values for the filter curve are the selections. So that means, well, the color of the selection here is nearly black. The value of the input is low. So the black parts correspond to this part of the curve, while the deep red parts that are the highest value of the selection, which correspond to this part of the curve. I will now, maybe you haven't seen it, I will now create a curve like this. Oh no, I want to give it there and there. Which would mean that the highest part of the selection, the highest values, are in the output, so the kind they are used, low. And the highest values of the selection are now the middle parts of the selection. Just have a look what it does to our terrain. I hope it is good visible. The tops of this terrain have now more or less noise structures, and the middle heights are ridged to here, and the low heights are not ridged. We can copy and paste the curves. I will copy this curve to use it in the shader. Paste it here. Alpha power to maximum. And here we can see it colored where the mountain ridge filter now was applied with which power. Here no power in the top parts, and the maximum powers are in that deep red parts. So using the filter curve editor together with the selectors, with the selections, give us really much control about the generation process of the terrain. To use the filter curve sel1, it is very important that we use a fuzzy, a great fuzzy, not fuzzy, fuzzy value, because there is nothing to translate. For example, I will now, no. I will add a selection. With absolutely no fuzzy factor. We can see this is also a selection of the middle heights. And I will now use this selection, not the selection 3 in this case, with that curve for creating. Well, let's have a look. Okay, just to explain it. I've used the red coloring, use a selection 3, which is here selection 3, with a selection of the middle height of the terrain. I have applied to this selection this filter curve, and as we can see in the rendering, there is nothing red, and also ridges are nearly not visible. Well, what's the reason? That's the highest value of the selection. Here, that's the output of the selection. So the input of the filter curve. This is the absolute maximum value, and if we can see here, the maximum value, the maximum input value has an output of 0. I will just change this, render again, and now we can see the selection. But also, we definitely have only two input values of this selection. The one input value is 0, and the another input value is a maximum. I will now simply invert the selection. As you can see, now all is selected outside the selection with this small filter curve of this small part, and we can even make it smaller without any problems. We only need one line. No difference. As you can see, using the filter curve editor without a fuzzy, like here, without a great value of fuzzy, does not make much sense. The filter curves need a coverage of the whole possible values for input and output. Now I have added fuzziness, and we can see we have now parts to translate. Again, I will make oh, sorry, you can't see it. Again, I will make a simple curve, generate and render it. Well, let's create the selection and let's have a look to our curve to see what has happened. The maximum values, which are in the mid height, are lowered. The low values are still lowered, and these small parts with the middle value have now a very high value. That's the reason why we have only here some ridged parts and here some ridged parts. Let's reset it. The translation 1:1, and it is now very good visible that the ridged parts have grown very much. But we have forgotten to reset also this filter curve. Okay. Now we have again the same filter curve for the texture red and for the generation. And it is very good visible that inside these selections we have produced ridges, outside no ridges, and at the tops, which is outside the selection, also no ridges. Well, that was all for the first part, how to use the filter curves and together with fuzzy selections. We now will have a look at some different selection types we also have. I will disable height selection, enable orientation. But I think orientation is a well-known selection type. What does it mean? That according to the orientation of the surface of the terrain, a selection is created. I think it's good visible that the parts which are looking now towards us are selected, while the parts which are not looking to us are not selected. We also have here the fuzzy sliders. Well, the fuzzy sliders means that from the first slider selects the orientation. Oh, that's not easy to explain if we have no circle. Well, if we imagine a circle and we have, for example, selected the first half of the circle. The First fuzzy slider selects this part. I hope you can imagine it. And the second fuzzy slider, this part. So that is at all a whole circle if both fuzzy sliders have a value of 100%. We have a bit problems with absolute flat parts because the orientation in geocontrol does not make differences um, to the slope of the terrain. So it tries to recognize always an orientation of a surface, no matter how great or how small the slope is. So 0 parts will make problems with that with orientation. And if we now change the orientation, I will just set these sliders again to 0 to see better. We have now selected mostly those parts of the terrain which are looking from here to the left. So with this orientation slider, we set the orientation. The angel slider is comparable to the both height sliders in the height selection. What means 180 degree means 90 degree to the left orientation or counterclockwise, and 90 degrees clockwise to the orientation are fully selected. And so you have only here a black-white selection, full or nothing. And the fuzzy sliders fill the parts between the middle of this orientation on the other side, so in a degree of 180, to the borders of this selection. Just have a look again. No, Bell and render. I will now select a very small angel so that we get a full selection. As you can see here in the top view, the structure of the terrain is very good visible. This is with this selection, and it is very good for shading. You can mix orientation with some other selections and get very complex and very interesting looking structures for shading later. That's the orientation. Slope, I think slope should also be well known. Create it here and render it. So explain it again. Slope max is set to 0. That means, and slope min also to 0. That means the maximum value have slopes with have parts of the terrain with the slope 0, and from this it is blended towards the maximum possible slope. We can see here high slope parts which are nearly gray. Again, to get what we mostly would expect, where high slopes have high values and low slope has low values, we set the slope min slider to the maximum and the fuzzy slider also to maximum. And now we have selected the maximum heights, the maximum slopes of the terrain, and can use it, of course, very nice for shading, snow effects. We'll set it to white. Of course, now the snow is on the wrong part, and we get better snow effects with the opposite setting. So now all low slope parts have much snow, and with rising slope the snow disappears. For better shading we can use a noisy blend, which separates a bit this blending of snow and not snow parts. Well, let's stay with the snow and combine selections. Snow mostly we find not only on the lower part, but also on the higher parts of the terrain. So I will now use, without fuzzy sliders, the selection I created first. We can see we have a sharp border from the height, for the height, and inside this sharp selection of the height, we have the fuzzy selection of the slope. For a good snow, we need a bit blending. I take 20%. Yes, it's hard to see. It's no longer as sharp. If we render it now, we should have a snow-covered terrain. That's a very typical way for snow covering of terrains, which done is also with the same principles in all other applications. That's very unusual. Now there are two very untypical selection types in GeoControl. One is called relative. I will change back again to red for better visibility. Yes, just check the filter curve. And now have a look, what does relative mean? Relative means that we now select the relative position of a part of the terrain compared to the surrounding of the terrain. Let's have a look what that does mean. Let's first take a low value. Okay. We have selected relative min and 0 and relative max with a value of 2. It's not good visible in the 3D view. Well, I hope it is here visible. We have here a ridge. See it? A ridge. Here a ridge. And between the ridge we have low parts. Relative value of relative min 0 means that it is the lowest point of the surrounding. I hope we have some lowest points here. Yes, here only some. You can see the little red points here. That are the lowest points of the terrain compared to the surroundings. So they can also appear in the very high part of the terrains. Just let's do the opposite. And we now have selected the highest parts, the peaks. And now we have selected something like ridges. I hope it is visible in the 3D view. Yes, it should be. We'll zoom a bit. Here you can see that are ridges, and the ridges are relative higher than the surrounding parts of the terrain. And so the relative selector is able to select parts of the terrain according to their position. And the higher the bandwidth is between the both, the more of course is selected. I hope it is visible. It is not a question whether the terrain is smooth or not smooth. Because this value means, the value of 4 means that in the surroundings of a point, 4 points are lower. And the surrounding, if you, well, just let's take the grid to explain it. Oh, it's not good visible here. Well, this might be the point which we are speaking of with a selection. And then every point has 8 surrounding points. If this point is the highest point, it's a selection of 8, the relative position of 8. And if, for example, 1, 2, 3, 4 points like this are lower than this point, then it has a position 4. If it all are lower, it has a position 8. If 2 are lower and all others are higher, of course, that does it mean, it has a position 2. And that's what we can select with a relative selection. It can be very interesting for creation processes, for displacements, and sometimes also for shading. The last selection type, very interesting type, is called roughness. Let's have a look. On the first glance, it might be very equal to the slope selection. We have here the low slopes with the high value of the selection, and this high slope parts with a lower value. But this selection does not select the slope, but the roughness. And roughness means, you might remember the explanations about how the filter works, especially the mountain ridge filter. Roughness means the differences in slope. Oh, that was a bit too much. So we have now selected from 25 to 41, and this is degree. So the difference, the roughness means the difference in slope. The minimum difference of a slope for the selection is 25 degree, and the maximum difference is 42 degree with a fuzziness of 100%. And this selection enables us to exactly, for example, only select parts without great slope differences. And we can now clearly see also high sloped areas. Well, here we have not so much. Also high sloped areas can have relative low slope differences if they are smooth or flat. So the flatness or the roughness of the terrain is defined by the differences in the slope. And this is a very fine selection type for generation and for shading. And GeoControl is the only one software which offers relative selection and roughness selection. And now we are at the end of this first part of the selection tutorial, and I hope it's now has gotten much more clear how to use selections.